Hello, my name is Fred Korth, and this is my senior project on the design and implementation of an iPhone attachment for surfing. My advisor is Dr. Tally Freed. Here's a basic agenda of what I'm going to go over. I'm going to start with a problem statement, move on to the deliverables, the design process, experimentation, results, and conclusion. If phones were accessible while surfing, people could maintain essential communication with their everyday life, such as business or friends. There are no ideal solutions that allow this at this present time. Only two solutions are available on the market that aim at solving this problem. One is an armband attachment, and the other is a surface mount attachment. For the ocean-minded user, there are many more risks and aspects of design needed to be examined than those for swimmers in a pool, for example. Waves can break fiercely, which would dislodge armbands or adhesive mounts, such as the ones that already exist. The only two solutions on the market right now also do not allow any way for the phone to be secured while also maintaining full functionality of the phone features such as text messaging, internet usage, or even checking the surf report. The deliverables in this project will provide a design and selection of a phone holder, which will be analyzed using a hierarchical process, the creation of a working rapid prototype suitable for experimental use, and recommendations for the consumer market. For the design process, the engineering systematic approach is used to develop an ideal solution. It starts with defining goals, defining the stakeholders, the requirements, and then from there, developing alternatives, evaluating these alternative solutions, and selecting the most appropriate solution. This project aims at reaching the following goals: placing a high priority on secure attachment of an iPhone for a harsh environment, while allowing for maximum usability of the phone's features. Also, having a simple, easy-to-use design with minimal intrusion on the surfboard. The next step in the engineering systematic approach was defining the stakeholders. This project is aimed at the surfing market as a whole. Potential users of this product would range from the beginning surfer through the professional surfing industry. Basically, anybody who enjoys surfing and desires to have an access to their cellular device while in the water would be an ideal customer for this product. Manufacturing companies interested in this project could be any surf accessory company or phone case company, or even a new investor looking to fill a niche market by starting a new company. The requirements for this project, and especially this iPhone case design, need a final design that is feasible in the fiscal area, also the implementation and use in an ocean environment. This project required several design iterations for different attachment methods. The attachment method, whether it was going to be a flush mount, a surface mount, or an attachment on the person, needed to be analyzed with the end goals as deciding factors. Following the design iterations, a proof of concept needed to be established and tested. Following testing, an analysis was required, which included reporting out on the manufacturability of this potential product. The three main contenders for this project design were an adhesive surface mount, such as shown in the bottom of this screen, an armband, such as shown in the middle, or a flush mount built into the surfboard. The analytical hierarchy process, or AHP, was conducted to decide which type of surface mount or flush mount to use in the design process. The AHP evaluates the 3 attachment styles, ranking each based on the phone's usability, its product cost, the stealthiness of the product, phone safety, and the attachment weight. This is combined with the user input ranking each category and its importance. The AHP process elected that the flush option was the most beneficial. These 2 diagrams are examples of the very first iteration. These are too bulky and difficult to manufacture as well as install. They would require a very large cut into the deck of the surfboard, which many users would not be pleased with. From this design, several more iterations were created until the final model was chosen. This design maintains many similarities between a very common fin system that surfers use all the time called FCS. It's a system based on plugs, as you can see on the right side of this screen. The black plug goes into the deck of a surfboard and is secured there with fiberglass resin and cloth. The 2 tabs on the left side of the back of the iPhone case, shown on the left right here, fit into those plugs and get secured with a set screw. This is, although complicated, this is actually a very straightforward process for anybody that has ever installed or removed fins on their surfboard, which is very common for anyone that's ever surfed before. From this final design, it was rapid prototyped with a printer bot. The 2 fin plugs were purchased and installed into the surfboard near the front of the surfboard, which would allow the surfer to view the phone while paddling without inhibiting the surfer's movements. The placement of the plugs was carefully measured to ensure a proper fit with the rapid prototype proof of concept. It was important not to mount the device too far on the nose of the surfboard, which could create an unbalanced board and change the way that it rides. Installing the fin plugs is complicated for a first-time user, yet ding repair companies and surfboard shapers are very experienced with this, and it does not take any longer than 10 minutes to accomplish. So this is the final product with the fin tabs that are rapid prototyped and the 2 plugs installed on the deck of the board. The Allen screw, or the set screw, is screwed in with a common fin key, which is available at any surf shop for either free or $1. The rapid prototype was produced and functioned as expected. The waterproofing aspect of this design works really well. Testing was performed by running a high-pressure hose from many different angles and throwing the board around in the ocean. Ideally, this would have been tested in some larger waves. However, due to the rapid prototyping material, the strength of the plastics could not be verified, and the risk of losing the cell phone was too great. Were this designed to actually be manufactured, high-impact plastics would be a more ideal prototype, with beta testing in place before actually launching the product. The cost and quality estimates for this project were on par with the end product. The prototyping was of no cost due to an acquaintance having access to the PrinterBot rapid prototype at his work. The waterproof casing was approximately $80, with $6 on top of that for the fin plugs. The fiberglass and resin was $2 for this project. Purchasing resin in bulk could greatly reduce this cost to less than $1 per installation. The quality of the prototype was excellent in visual appearance and feel. However, the structural stability was somewhat questionable. This project showed that iPhone attachment systems are completely feasible for relatively low cost. The theory that this installation and the design should be very straightforward to users is verified. This prototype was completely waterproof and securely attaches to the board. The goals stated in the introduction were met. Several product designs using the engineering method were developed. They were analyzed, a prototype was created, and manufacturing recommendations were made. In conclusion, the main recommendation this project can make is that an iPhone case manufacturer should definitely perform a marketability report on similar mounting devices and potentially bring this product to market. Surfers, especially the weekend warriors, tend to gravitate towards technologically advanced surfing products and gadgets, and this has the ability to be the next big step towards bridging the gap between their working life and surfing.